Scott and I came up with we're thinking about basically the same topic the night before the technical research meeting. And then, yeah, that's one of the topics that came up on Monday and might be worth discussing a bit. And then I have two more kind of follow-on topics about modeling interactions between objects and deformations and how that might relate. But yeah, Scott, if you wanna, uh,
Sure. Yeah. As Vivian said, we were thinking about the same thing. I came at it from the angle of materials. Did you start with materials when you were?
yeah,
Okay, that's funny.
Is this like the
Um,
t-shirt problem? Is that what we're dealing with here?
yeah, like t-shirt, water, fire, clay,
Okay,
often this.
so I started working on that too. So,
Oh,
but go ahead.
okay,
cool.
We're
cool.
good.
Yeah,
Maybe something
it's
subliminally during the focus week triggered uh,
Yeah,
triggered
yeah,
that in
yeah.
our
right,
heads.
right, right.
Um, I think there's one thing about, say, water, for example, is that I've got a pretty good like if the laws of physics changed and the water started acting weird or it was weirdly viscous or something, it'd be something you'd be able to pick up on. We clearly have some kind of good behavior model for how that stuff is working, but I also don't necessarily have like a real morphological model for it. Like I can't summon
Are you
a
saying
water.
you don't have one, or there isn't one?
That's a proposal that there isn't one. That's
Okay.
defined by
So
its
I, c-
behavior.
I started with the opposite conclusion. I said, since I can infer a t-shirt that's crumpled and it's not exhibiting any behavior, I must have a morphology model for the t-shirt somehow that is not a behavioral model.
Well, so that seems like you're more identifying it based on its features, like the color and texture, and not by its morphology,
Well,
like its shape.
well, all right. Right. When I say morphology model, it's a non-behavioral model. It's a model that represents a static position of these things that I still say it doesn't fit in our classic morphology model at all. Right. I can't say where the features are relative to, in some reference frame. But still, my point is I can recognize a picture of water um, that's not moving. I can recognize that. I'm recognizing it right now. I say, oh, that's water. That's a fire. That's a piece of cloth. Even though there's no behavior being exhibited.
Okay,
So
so
there's
I
some.
think so in Vivian's here says there's no morphology model, and the way I was thinking about it was that if let's say there's a hundred columns that constitute the model of water, it would be like 90% of them are behavioral, 10% of them are morphological. That's kind of what I was thinking about it. There would be some small,
Well,
Well,
coarse amount of morphological model because, like you said, you just still have to map somehow onto, say, the surface of the water or something like that. Um, and I do have an idea of like water droplets. There are some kind of
well, let
canonical,
me let me let me let me. Can I just challenge you a bit here on this one, just
yeah.
but I think about water. Imagine I had all I could see was the motion bits, right? I don't see anything else. I just see where changes are occurring. Would I be able to recognize that? I certainly wouldn't tell you it's water. I might say, oh, that's a wave crashing, or I'm not sure what I would, but I wouldn't necessarily say it's water. On the other hand, uh, on the other hand, I can definitely
well,
recognize any picture of water, right?
I
Um,
think you would if you
Can
had
I
just
share
a
my
set of
screen for a
particles moving and
sec?
you had like a your cursor would be like a spoon stirring it. I feel like you would be able to recognize whether it's water or some thicker
Are you,
liquid or
are you guys
I,
seeing
I was
this?
I was thinking about.
If,
I see it.
so yeah, like something like
Well, in this case, I can see both the physical structure and the behavioral structure. Um,
yes, I guess the reason
yeah,
I
Yeah.
was saying there's no morphology model is because I was thinking of there being at least three types of models. Kind of how we talked about a couple of years ago, that there's a morphology model, a feature model, and a behavior model. And the feature map is about the relative arrangements of things like color,
okay,
but it's not
right.
defined by like point normals and 3D shapes. It's
So,
more,
so right, I agree with that. But then I would say, as opposed to introducing a third model type, I said,
yeah.
look, there seems to be a continuum between structured morphology models that are very rigid, like our cup, and then classes of cups, which are different. They don't have structured, but they're not just a bunch of you know, there's a continuum between very precise and very imprecise on the morphology side of things on the static picture. So I wouldn't introduce a third one. I would say, how do what we call today a morphology model, quote unquote, how can that accommodate your feature model? You know,
Uh,
how can one column do both?
So I guess I feel like it could be a separate type that gets input that's not about point normals in 3D space. It's more about features with local neighborhoods. So um, hang on. Like there might be simplistic features of the material, like the color and the texture of clay or water or fire. But there's no shape to it. There's no specific shape of the water. I don't have like a three-dimensional shape model of water. I have a model of how water behaves when I interact with it, and I have a model of the low-level features of water, like the color and transparency and potentially
Okay, we
temperature.
can all agree. I think I agree with that completely. I was just trying to put two of them into one. I was trying to accommodate your
Yeah,
feature model and your morphology
it
model
feels like maybe
in one
they're.
learning module.
I feel like there may be complementary things. Like one is kind of almost related more to the like the example you've talked about recently, Jeff, of the intersection where and where
Yeah,
we talked a couple weeks ago about how like having child objects should enable generalization because you can be, for example, recognizing different cars because you're just looking for a wheel and so yeah, so maybe
yeah.
that's part of it. Like the t-shirt is like you're just recognizing the collar, you're recognizing the sleeve and these local objects. And then another part of it is basically you can have pretty rich local features that aren't morphological, like you say, Vivian, like the texture of cloth or the texture of water, and those are in some sense kind of model-free features that you extract, and those can be quite diagnostic as well. Um,
I guess the question is, are they in separate learning modules or are they in the same learning module?
I,
That's the only
yeah,
I mean,
point we should
personally,
talk about here.
I feel like, yeah, personally, I wouldn't put them in separate ones. It's just a case of what kind of inputs a column is getting, but I don't see why
yeah, but
there's
then
any
they
reason.
wouldn't they be in separate ones if the column is getting different input? I mean, I again would say it's the
Why
exact
is it
same
different
type of
input?
column, same
Well, because
mechanism,
one
but it
one
just
type of input is child object. So like any column that's in a hierarchy can have child inputs. The other one is just like instead of color, it's like yeah, I don't know, some sort of texture.
Well, this is very similar to when we discussed behavioral models and morphology models. At first, we tried to put them all together, and then at your urging and arguments, and we separated them out into two separate models. And I said, okay, I can justify that. But we can call this the what and the where pathway. Okay, makes sense. Now we're in the same situation here again. I started asking, how could I take what we call today a morphology model and get it to do both? Get it to say, okay, I can handle looser morphology to no morphology, little like edge detection type of morphology, or point normals on a reference frame. So can I handle the spectrum of these? So my assumption was the same learning module that can learn an intersection could learn a mod. And you're saying no, maybe they're really two separate things, and so maybe I recognize certain objects, in which case I might call them classes of objects because they're really not. They don't have a structure. They don't have a strict physical morphology to them. They vary. So you might say I have a sort of a class object, and then I have a specific object, something like that. And the class object is not reliant on reference frames and point normals. Would that be
yeah.
correct? Sort of somewhere the points here.
Yeah, and it's still like an object ID. It would be the ID of clay, but it can have various shapes. It always has the same behaviors, but there isn't one morphology for it. There are like an infinite
Right.
amount of
So
morphologies
to
you can
me,
pick.
it wasn't about materials. To me, it was like I'm also trying to accommodate the fact that you can have various morphologies under a certain class. So I was looking
Yeah.
as a spectrum of like, oh, it's there's the rigid T-shirt that's mounted in the picture or hanging on the frame or whatever, and then there's one that's folded, and then there's one that's just a pile. Um, there's a continuum there somehow. How do I represent that continuum in a single model as opposed to you're saying, no, I have two models. one is really materials based, but that wouldn't be sufficient in most cases.
Yeah, I mean, I
Um,
think you can have multiple models active at the same time. You can recognize this is the clay material, but you can also recognize it's the shape of a vase and that it has a morphology of a vase
right.
or a bowl or
Well, right,
whatever.
but I don't think what it doesn't seem to solve is my need to recognize a class of coffee cups that are all different shapes. I don't.
Yeah, it's
That's
not a
more than just
class.
materials,
It's not a
right? But
class in
that's
that
part of the problem.
sense.
Yeah, I
Right,
get
but
it.
that's the
I feel like
problem
there's
I
a
was
slightly
trying to
different. I feel
solve.
like right. I feel like to me the like what we kind of talked about before, the child thing could still help with that. Whereas I feel like this is kind of arguing like essentially that these are columns that maybe have a reference frame, like they have an L6, but essentially atrophies because they don't use it because that isn't providing any predictive power. Is that maybe a way of kind of phrasing it? 'Cause, I mean, I think that's an interesting idea that
I'm not
like
sure if we've gone through enough examples to say something that strong. I think that's interesting
Yeah, I mean, I was
uh,
thinking of the feature
proposal.
models as kind of like the 2D sensor module, where it's just a different type of, like, it's just a different type of reference frame or a different type of movement info that you get. And maybe it's a very impoverished model that just stores, oh, this is bluish colors. Um, and there's no
Right.
structure, but
So,
there might be like a pattern on a carpet or whatever, and that has structure at the lower level, and
Right.
then
but then
is applied.
isn't that
you
just
know,
kind of a type of morphology model? How is that kind of that different than
Well, can I bring up an
The
example?
subpart, yeah.
The shine of this mug over here, just the reflectivity of a surface or something. It's something that
what about
changes
it?
the features all the time. You walk around it, but you don't bake that into your model of the object. It's not like you bake that feature into the location. You're able to sort of somehow learn something about the reflectivity of the material, and it seems like, it obviously maps onto the mug in some special way that's related to its morphology. You see these vertical stripes like that, right?
Well,
Um,
actually, it's nothing to do. Now, there's an example of properties that have absolutely nothing to do with the mug, but they have to do with shapes in lighting,
And the
right? And
material.
materials in lighting, in the
material,
material.
yeah. It's a
So,
material,
and I'm gonna make one more observation. We have the same problem in the behavioral models. Today we think of behavior models as being very precise. Where are the moving features relative to each other, like in the light switch or the stapler? But like in the example of the waves in the ocean, there's no clear, obvious relationship. It's more like a crumpled T-shirt. The behavior model of waves or crashing waves at least, it's more like the crumpled T-shirt. There's no strict position of things, and yet somehow you're able to recognize it. So if this is if our goal is just to introduce the topic for a future discussion, I might say, well, we have several overlapping things. We have the issue of being able to recognize classes of objects that are not strictly in the same morphology. We have the ability to recognize things basically on material properties. We have the issue of even in a strict morphology like the mug, we have different reflectances, which essentially are different observed features, but we don't see them that way. So those differences are ignored. These are all maybe related problems, and we could try to think about all or some of them at once. Is that a reasonable like summary of the area we're talking about?
yeah.
yeah. I'm
Yeah, I
And
not
guess.
quite picking up on the object class thing. I may have sort of dropped that part of
It's
the,
just that our current models do not explain
yeah,
how it is I see a different type of mug and recognize it as a mug.
right.
It, it,
or I mean, we've discussed I guess ideas for how it might work, but we haven't demonstrated that it works.
we haven't demonstrated. And when to me, the mug is the t-shirt is on a continuum of there. The classic t-shirt, we all know what it looked like. If I asked you to draw a t-shirt, you would draw it as if it was laid out flat, ironed on the floor. That's how we would draw it.
Hmm.
That's our morphological model of a t-shirt. Yet I can recognize the t-shirt with a fold in it or another fold in it, or if it's it's got some wrinkles, and then I can still recognize if it's just in a pile on the floor. So there's a continuum of strict morphology to like lacking complete morphology. Um, And so I'm viewing it as a continuum, but as opposed to two separate models. Anyway,
Yeah,
that's
I
why
think
classes come into play.
the idea I thought was interesting is that maybe that's what you're referring to as classes, but that behaviors themselves can define concepts that we have. Like water is really mostly defined by its behavior, and the low level kind of features. It's not defined by its morphology, and so yeah, you could call it a class, but I would just think of it as like whenever a certain set of behaviors is detected, we call that clay or cloth or
Right.
whatever.
So let's follow that analogy. You could say I have the spectrum on the morphology models, and I have the spectrum on the behavior models, and I can identify something anywhere on that spectrum, either behavior or morphology. So there isn't a strict behavior of water. Sometimes it drips, sometimes it splashes, sometimes it sloshes around, sometimes it's running over the counter. I can't say there is a strict behavior for water. Although there might be, if I watch my faucet dripping or something, I know exactly how it's going to behave. So I'm just saying there seems to be this continuum of both morphology models and behavior models where you go from strict morphology to very loosely defined or undefined morphology.
Yeah,
That's
but then yeah,
I,
I guess I think just in terms of this kind of stuff, I think that yeah, what Scott and Vivian, what you guys had brought up on Monday, just that the emphasis of behavior modeling for these kinds of things, I think is an interesting kind of just perspective switch. Um, Obviously, I think we were already talking about like, oh, cloth has a behavior and water has a behavior, but just really emphasizing that yeah, when we think about these things, model these things, so much of it is really just down to behavior, that to the point that it's almost as if there's no morphology model. But I also agree that there
I,
is
I,
there is there is there is
let's
some
get
other models that
I,
are able to recognize it.
right.
Yeah, and I
I
mean, I
disagree with
wrote
that.
you can learn morphology models for very specific configurations, like the folded t-shirt or a block of clay. Um, but what makes fire fire and water water is how it behaves and interacts with other objects. And it's not like there's one behavior for fire or water, but they have a very specific set of behaviors, and you can make very specific predictions of how it will behave when you interact with it. And that doesn't change no matter whether you have a cup of water or uh,
Right.
the
Well,
ocean or
again,
whatever.
I think the fact that I can recognize the T-shirt when it's crumpled or folded and it's not exhibiting any behavior tells me that it's not just the behavior model. I'm saying it's both. And if we just focus on behaviors, I think you're going to get it wrong. Some things
Yeah, that's
like
the
the fire.
simplistic feature models of the material without the. But yeah, maybe that is a very coarse type of morphology model that it just. Yeah,
I,
I
I don't know
agree.
how
Yeah,
it
we need
works yet.
some kind of representation of the color and texture and all that.
So I'm just saying there's a spectrum of strict morphology to non-morphology, and that spectrum exists in both what we call this, let's call it the static models, right? So what we've been calling morphology models are static. They're just static. I'm looking at an image or something. And that spectrum exists in the behavior models too. So a
Is
staple
this
has a very precise behavior model, and yet fire has a very imprecise behavior model.
Yeah.
And we can debate whether we have to introduce new learning modules to do this or not. So that's an interesting question. New types of learning modules, or can our existing two learning modules accommodate the spectrum of strict reference frames or non-strict reference frames?
yeah, I feel like one interesting thing that came out of this was just whether there's instances where we might embrace like poor path integration almost, or kind of like whether that might just be a learned signal that movement isn't going to tell you that much about what you're going to perceive once you're kind of on an object. I don't know. Like the example of
One of the things, one of the
clay.
things that occurred to me was when you look at a crumpled T-shirt, I believe you can do that with flash inference. So that was a clue. It doesn't tell you an answer. I don't have to, I don't have to look at it and scan over it. I could just flash it in front of you and you say, oh, yeah, that's a crumpled t-shirt. I didn't test that, but it feels like that's true. And that's a clue to the answer here, because that means I have multiple columns have the same similar model, and they're all reaching consensus based something about where they are in their location, I think. Because if you just, I think, but maybe I'm wrong about that. But
Uh,
it feels like
yeah, I'm
there's
not sure
definitely
if you'd be
voting
able
going on there.
to tell different pieces of clothing apart from each other, or if you can just tell that this is cloth and it has the color of, I don't know, your favorite t-shirt or something. Like, I
Yeah, I
feel
think you
like
can definitely
you're
recognize materials, like even just with a straw
But
without moving.
Robbie, obviously, if it's just a pile of fabric and I don't see any features on it, yeah, there's no way you can know what that is. But I think the folded T-shirt or the one with the big wrinkle down the middle, these are all examples of things that don't fit properly into any kind of our existing framework of reference frames. They don't fit neatly, but they do have physical structure that's important. It's not just a pile of cloth. It's like, okay, even just a t-shirt that's got the corners folded over and you only see parts or something. I mean, you still recognize it and you know what state. If I flash that in front of you, oh yeah, that's a t-shirt that's got the bottom's folded up. You know, it's like, how do you do that?
yeah, I guess
I don't think we should
one
argue it too
other
much
part
here.
was yeah.
Yeah,
Yeah,
go
but
ahead.
Scott,
What's the other
you
part?
had something you wanted to say?
Well, so I was just thinking if we sort of leave the idea of an entire t-shirt aside and just think about the cloth of the t-shirt, um, it and it's folding, it's got sort of folds where like the way a flag waves. I would say that's
Is it
probably the
wait? Is it
essential.
moving or is it static? Is it static or is it moving?
So there, when it's folded, it's static, obviously. A fold is static.
Okay, so we're talking about static. So there's no waving going on, right? It's just a pile. It's a pile of poop,
So
right?
what I'm saying, yeah, but a behavior model would on a folded little, I don't know what you want to call it, one of these little creases things, a behavior model for it, for say cloth that's being manipulated, is going to look kind of like this. It's just sort of a smaller, more
Yeah, but
primitive.
I think when I see a pile of t-shirt, I don't imagine any behaviors. I can imagine, oh, how about I straighten it out? Um, but I don't look at it like, oh, that's a flag flag, or that's a t-shirt that's crumpling. It's more like that's a
Do you
pile of
think
pile
though
of
that certain
t-shirt.
morphological characteristics imply a behavior? Because if
I
they
mean,
Well,
they're
certainly in
imply a
many
they're
behavior,
definitely
certainly,
predictive of it. Yeah, like
right. In
there's
many
an
then the
cases,
association.
aggregate of those behavior
but
models
but
constitutes what
but
we
I
think
you know
of as a
I'm
material.
struggling. I'm struggling to tie the crumpled t-shirt with behaviors. I don't see it. It's like it's got a shape. I recognize the shape. I don't imagine it was folding into that shape. I'd say, oh, there it is. That's it. There's my t-shirt. Now, obviously, I had to see something. I had to see like a collar
Yeah.
or something that tells me it's a t-shirt. But those are features, and they're not behaviors.
So
I,
I'm
I'm
gonna
not
flash
convinced.
a crumpled piece of clothing, and you can guess what piece of clothing it is.
Okay.
Did you see
Dress
it?
shirt,
Well, that
Sorry?
one I didn't see any.
a dress
I didn't
shirt.
see any unique features on it.
Yeah, I
I
think
just
that's
saw
the
cloth.
issue
A
because
cheat.
you can't rely on the morphology. You have to rely on specific low-level features to recognize it.
But there are these things that I keep pointing out. There's in between points, right? I agree with you. But there are also these in between points where it is clearly a t-shirt, but it's not in its classic form.
Yeah,
That's why
but
I keep saying,
I think
imagine a
you
t-shirt.
recognize it because you recognize something small on it, like the collar or a button or a sleeve or something. You
Yeah.
don't recognize it because it has this global shape preserved or you have a model of that shape. It
Right, I
matches that
agree
Yeah.
with that.
model.
I just feel we have to be able to handle a continuum of these things. So that's my only argument. It has to be a continuum. Sometimes it's got strict structure, sometimes it doesn't. And and by the way, when I take a t-shirt and it's only partially crumpled, like it's kind of scrunched up, those features are not in the right position, but they're in the right relative position potentially. So there is definitely a reference frame type of relative displacement coming into play. It's
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 also
not
weird
like
because
I
like
just see.
if you were to cut up a t-shirt and have a sleeve and a collar all placed in like a pile, obviously you're adding features as well, but but you wouldn't look at that and be like, oh, that's a normal t-shirt.
Yeah,
I don't
but
know.
Right,
that's
Yeah,
right.
because you have different low-level features now. You have cut edges that you wouldn't
yeah.
normally encounter on a t-shirt. I think if you took a t-shirt and you cut it in half, or you sewed on the sleeves at the bottom of the t-shirt and you crumpled it up, I don't think you'd
If
notice
you
that the
crumple
sleeve
it
was
up all
sewed
the way,
on.
but my point is I want to go for the in-between states, the ones where it's not crumpled up all the way, but yet the reference frame doesn't work very well. So I'm not denying that we have to do the completely crumpled thing, like this thing you just showed us. But I think to say I think it's on a spectrum. That's all I'm saying.
Yeah, I
It's on a
can agree with
spectrum.
that. Yeah. Yeah, I'm
You know,
just saying that
I was
there
just
might
imagine.
be very simplistic, just feature-based models that you can use to.
I was thinking like sometimes this is kind of a gruesome thing, but I was thinking about a crumpled t-shirt. I said, what about a crumpled car? Sometimes I see cars that have been in accidents, bad accidents, and they're on the back of a flatbed truck, right, being towed away, and it's all completely malformed, right? Um, so the wheels aren't in the right place, or maybe one's missing, and the hood's here, and the body's crumpled, whatever. And yet, if I had rearranged the pieces there, I would say that's not a car. That, like, what did they cut it up or something? I would somehow know that that's not right. It's not like the features themselves. It's the features still in some positional relationship that matters. Um,
Yeah, like something
and
almost about the continuity in space between the collar and the sleeve is like a signal. So like it's
right.
almost like it's almost like that surface is continuous. Um,
Or there's
that's
some
connecting
relative
them.
position of things. I would keep
And
going
you
back
can
to the
distort that
t-shirts.
surface, but yeah.
It's clear I can make a t-shirt that's not really a t-shirt. It has arms and a collar in the wrong positions, and I can crumple it on the floor, and I won't be able to tell what it is. I won't be able to say that it's wrong. But that's the extreme. There's a lot of in-betweens where they're like the crumpled car. It's like you just can't take a bunch of features and throw them in. You're not going to get fooled by that. There's some things that you're just saying, yes, it's distorted, but it's not completely distorted. And that's my sort of class example. Anyway, when I started working on this problem, I started thinking about trying to put these parameters on what the solution would look like. I came up with a different conclusion. I concluded there was a single model. I didn't conclude this. I was working with the idea that there's a single model that handles a spectrum of morphology strictness, and I didn't think about having a separate model for some things. So that's good possible. I'm not saying I'm right. I'm just saying as we think about this problem, that's how I was thinking about it. So I was
Yeah.
focusing on the in-between states, like the t-shirt that's not completely crumpled, but just a little bit messed up. How do I recognize that?
Yeah, I think
You
maybe it
know?
relates a bit on the other topic I wrote some points on, which is deformations, where you
Right.
have an existing model like the tree, but then it can bend in the wind. You can still recognize this. We're not seeing it bend. You're just statically looking at it and you still recognize the tree or the clay being deformed. You still notice the
Right.
same thing, or like a stress ball. You can squish it and it changes its morphology, but you can still make predictions about it. And so I guess like
Right.
while
That's
the
a good
object is
the tree is a great example. I like that one a lot.
it, cool, yeah, it also has wind in it, so maybe eventually we can.
Well, I didn't see
Uh,
that. I didn't. Now you point out, I
yeah,
didn't see that
it
before.
was it's not that important, but yeah,
Because you don't have to have wind for a tree to bend over like that. The tree could have gotten
yeah,
bent for some other reason. Like, you see trees like that bent all over the time.
right. So yeah, while you're seeing the tree bending, you could have a behavior model for this and recognize that behavior of the tree bending. But you can also recognize it just looking at this image. You can still see it's a tree. Um, and yeah, while it's bending, different states in the behavior model for a deformation could associate with different morphological models. So you could have a morphological model of the tree in the bent state. Um, but when we recognize a deformed object, that seems a bit unrealistic to expect that you've already learned a morphology model of the tree in this shape. So what I would propose is that we just recognize a feature map. So basically, how the brown parts of the tree are relative to like have local neighborhood relationships to the smaller branches and to the smaller leaves. Not like a static
So,
3D
so you're saying
morphological thing.
these are relative positions then? It's
Yeah,
opposed to
it's right. yeah, it's just about, oh, here's brown, and next to that should be brown again. Next to that should be a smaller branch, and next to that
Right.
should be a smaller leaf. But it's not. It's more like a grid mesh, like a
Yeah.
two-dimensional
Do you
grid.
remember?
Then
Do you
yeah,
remember the beginning of this whole project, way back when? We had a lot of debates of whether the models that are learned by the brain are models of relative positions or absolute positions. We had a lot of discussion about this,
yeah.
and there was a lot of things recommending relative positions, and I don't remember all the discussions we had, but that this would be an argument for relative positions, not absolute positions.
Well, yeah, I think we do have relative positions, I guess, in a sense, but the
Well,
space
that's what you're arguing
preserves,
for. It's
like there's a metric space
right.
that preserves relative relationships between all points to remain constant. But in this feature map, it would just be local neighborhood relationships that are roughly preserved. And you can kind of wiggle these connections.
Yeah, I mean,
So
Right. It's the question
isn't
is,
it just like a small morphological model? Um, just covering a kind of smaller region. So it's like we have this child
yeah,
kind of recognizing leaves near twigs.
maybe,
Um,
but since
yeah.
you can infer the object with a flash inference, there must be a model of the whole thing. I was using, by
well,
the
but
way, in my one of
those
the
might be
examples,
kind of diagnostic enough to just strongly predict. Okay, if I
maybe,
see
but that
that small area, then it's probably a tree.
Yeah.
uh yeah, but I don't think so. It doesn't feel right to me. I was using a tree as one of my examples, but not a deformed tree. I was just using the fact that trees have lots of different shapes. And they have different leaf patterns and different branch patterns. And I flash any image of a tree, I say it's a tree. I might be able to say, oh, that's an oak tree or a live oak tree, or that might be an elm tree. I might, if you're good, you could do that. Um, but so our model of a tree, even non-deformed trees, is able to accommodate a huge amount of variety. Um, and so we
I
don't
mean,
really
yeah,
have
I
an
feel like that's
explanation for
getting more
that.
to class. I think that I feel like
Right,
that's
but to
an
me, these are all the
orthogonal but also
same.
important problem.
Yeah, but
I
yeah,
don't think
it
it's
is
orthogonal.
related, I
I think
think,
they're all the
because
same.
there, yeah, here
You think
there's
so?
also you can recognize tr leaves and branches. You maybe the feature map doesn't care about their relative arrangement too much, but just the fact that they are leaves and branches lets you recognize the tree.
But how do I accommodate into our
Well,
existing models?
yeah,
I
I mean, because you can have conifer trees and you can have deciduous trees, and even locally they look totally
but
different.
even
So I feel like
I
that's a
don't know how to
different thing.
handle I don't know how to handle a leaf in our models if I don't know where it is. Usually it's different locations. Well, where do I store it? What is my model storing? It can store a precise picture. There's a famous cypress tree in California. I can imagine that picture. Um, but it also I have models of somehow that accommodate. There's no precision. There's no specific
Right.
location for things, but it's relative. Um,
Yeah, it's like relative, but it feels coarser. I guess one thing maybe I don't know if we should wrap up soon, but to think more about or whatever. It's not clear to me, I guess, why the feature maps or whatever would need to be 2D. Um, like I feel like we
the-
could have coarser models or local models without them necessarily going from 3D to 2D. Or like that feels kind of like a separate thing.
was
Um,
that part of the proposal? The 2Ds,
At
2D.
least that's how I understood what you were saying, Vivian.
Okay,
But maybe.
okay.
well, yeah, in a way, they would have to be in a way that they can easily be mapped onto different objects. Like,
Um, but can
Yeah.
I just like associate a one 3D object with another 3D object, like a car
well,
tire with
none
a
of the morphology is changing a lot. Like with the tree, the morphology is totally different, but we still have the same kind of feature map, features on it. And we want to be able to map it onto that new morphology.
I guess I'm just wondering whether the way I would map that in my head is like I have this like trunk bending thing, and on that there's the child objects of like a cluster of leaves or something like that. But it's still a 3D. Still a 3D representation.
Yeah, maybe it helps if I make some more concrete figures of how I'm thinking of it. And maybe this is a bigger topic that can't be, it is a bigger topic that we can't solve today. Maybe
Are
just
we going
very
to talk about
briefly,
this
the last
Wednesday?
point.
Is that the idea?
We
Sorry?
could do. We have a lot of upcoming
Is this?
topics, but yeah, we could potentially continue this
I'm
next
sorry.
Wednesday.
Are we talking about what we're going to talk about Wednesday, or not, or is this just orthogonal to that? Okay.
Yeah, I mean,
I'm wondering, should
I
I
think
think about
this
this in the next week?
maybe, yeah, it might be a bit less important than the action outputs, but
I
yeah,
mean,
just kind of,
it gets to deformations and behaviors, which is really important. So
I think. By the way,
mm,
I think it also gets the class. I think this is the foundational problem of class of objects. So you might disagree with me, but I mean, that's where I'm thinking right now. So we'll debate that.
yeah, I
All right.
definitely
You
see
want
how
to
it
talk about one
relates
more
to
thing?
class, I guess. Yeah. Um, yeah, I guess just the last point I had, which might be interesting, is that um, when we make predictions about a deformed model, in a lot of cases, we might just be recognizing a different morphology model that we've already learned. Like with the egg morphology of Dali's clock, we recognize the morphology, even if it's not our clock's morphology model. We can make predictions about where to sense things. Or the bent tree morphology, we might have a model of a bent branch or something like that that we recognize to make
All right. All
predictions.
right.
Or bowl morphology in the case of the clay. Like a lot of times when you shape clay into different shapes, you then start recognizing those shapes and use those models to make predictions. And then if that's not possible, it seems like we're able to build a coarse temporary model of that specific morphology to be able to interact with it. Like when you're in the process
right,
of shaping something in clay or you made
Right,
a
right.
image.
But the other hand, it doesn't explain how I'm able to infer these new ones very rapidly.
Yeah.
Right. I could learn them very quickly. Right. I could very quickly say, oh yeah, I was molding the thing like this, or I left my t-shirt in that state. Um, but I don't see how you can recognize them because having a chance to learn them.
Yeah, yeah, but it might be in a lot of cases, it might be that the first solution covers a lot of cases that we actually have a lot of morphology models that we can already map
Okay.
onto a
So
lot of these
when I
informations.
thought about the tree, I might have a lot of different morphology models of trees. Yes, I recognize a cactus and a saguaro cactus and this barrel cactus, and I can recognize a yucca tree and so on. But even within that, there's just huge, unpredictable something about the leaf mass or the actual branch shapes that I can't model. I just can't do it. Uh, I don't have enough.
Yeah,
I just there's a new tree and its branching is different. Yet I can tell if it's right or wrong. It's like weird.
yeah. I mean, here I feel like you might recognize like a bent structure, and that would be useful for quickly building a representation. But then it's like the local stuff that tells you it's a tree. Like nothing about that says, oh, this is a tree. Um,
yeah,
but that's a useful model to invoke for understanding what you are looking at right now.
yeah, and for
And
predicting
understanding that
what,
I don't know, you could climb on top of it and kind of sit on the side or whatever. Like, um, and
yeah.
yeah,
Okay, but yeah, we can
Hmm.
continue this another time if we want to wrap up. Had a couple of
Yeah.
thoughts also on modeling interactions because it seems like there are lots of behaviors that are actually about two objects interacting with each other instead of just one object having a behavior. But we can go over that another time.
What? I want to pick up the one up that they refer to how two objects interact with each other.
yeah, that
Yeah,
would be
like
really interesting.
the behavior of
We've not
How,
talked
how's this?
about that.
How's the scissor do that? What's that?
because you have
How's
the
the
behavior
scissor
of
an example?
cutting, and that's about moving. Like just because the scissor is moving in this way, you wouldn't predict anything to be cut. Only if scissor meets paper, you'd predict the change in the paper morphology, but not if scissor meets, rock or something. And so it's really about the interaction between these two objects, or with magnets or with Velcro. It's really about the two parts that how they stick together and how they behave as you apply force
Hmm.
and pull them apart. Or with a drum, the drum itself doesn't make any sounds, but when you hit it with a stick, then the drum starts making a sound. Those kind of things.
I guess I don't see this as clearly an issue, but I'll take your word on it. I'm sitting there. Really, is this a
If I had
separate
the,
problem? Yeah, the drums just.
I like the paper example because it, I think, nicely illustrates when you say paper versus like a sheet of metal or something. I think it nicely illustrates how materials are predictive. of
Yeah.
what, that's a very useful thing to know about the world. Like if you just scroll to the right a little bit, it segues right into this idea here, which is like
Yeah. Oh
you've
yeah,
never
that's
seen this
a
wooden bell. You could strike it, it's you can picture it's not
It's
going to sound like
it's
metal, you
funny.
know?
I didn't see it as made of wood. I just saw it as a patina on it. I thought it was metal.
How can you do that?
Um,
How can you kind of imagine this woody kind of strike it's going to make without having some mapping some kind of material like thing? Because it's multimodal too. It's not even just like how do I deform
right.
this
So,
thing?
so that right. Well, so these are all good questions. So we have a ways to go.